Welcome to Spring LIB.
Let us first calculate the polar moment of inertia of shaft AC. So it will be JAC is equals to pi divided by 2 RAC to the power of 4. Let us put the value here. So it will be pi divided by 2. Radius is diameter divided by 12. 2. So 25 divided by 2 to the power of 4. So it will be equals to 38.349 multiplied with 38.349 multiplied with 10 to the power of 3 mm to the power of 4. So we will write it as JAC is equals to 38.349 multiplied with 10 to the power of minus 9 meter to the power of. Now let's calculate the angular velocity of shaft. So it will be omega is equals to 2 pi n. So it will be equals to 2 pi multiplied with n. N is given as 50 revolution per second. So it will be 100 pi radian per second. Let us now calculate the torque in section in shaft BC. So it will be torque in shaft BC is equals to power divided by omega which is angular velocity. So power is given as 3 multiplied by 10 to the power 3 watt and omega we have calculated as 100 pi. So from this we get torque in section BC is 9.549 Newton meter. Let us now calculate the maximum shear stress in the shaft BC. So it will be tau BC is equals to the torque in section BC multiplied by the radius divided by the polar moment of inertia. So the torque in section BC is 9.549 which we have already calculated multiplied by the radius is 12.5 mm. So let's convert it into meter by multiplying with 10 to the power of minus 3 divided by the polar moment of inertia is 38.349 multiplied with 10 to the power of minus 9 meter to the power of 4. So from this we get the shear stress in section BC is equals to 3.11 megapascal. So this is the maximum shear stress for shaft BC. Maximum shear stress for shaft BC. Now let us do the calculation for shaft AB. For shaft AB, the torque in shaft AB TAB will be equals to power divided by omega. So the power in AB is 1000 watt divided by omega is 100 pi. So from this we will get it as 3.183 Newton meter. Let us now calculate the maximum shear stress in shaft AB. So tau AB max will be equals to torque in section AB multiplied by radius divided by the polar moment of inertia. So the torque in section AB is we have calculated as 3.183 multiplied by the radius is 12.5 multiplied by 10 to the power of minus 3 meter divided by polar moment of inertia is 38.349 multiplied with 10 to the power of minus 9 meter to the power of 4. Or from this we get torque shear stress in section AB is equals to 1.037 megapascal. So this is the value of maximum shear stress for shaft AB. Maximum shear stress for shaft AB. Maximum shear stress for shaft AB.